All right, welcome back, everybody. And we have been in there's some absence of us because some of the traveling, some of us have some holidays. So I'm really glad we are finally back to business. So today we are going to cover a very important topic. If you do have any kind of practical smart contracts, called oracles. So before I even start, I think how many of you have heard about this term and what does it mean in Bitcoin and also in smart contract space? Anybody heard about this term before?
Yeah, I heard so it means some external provider of information which not be possible to do on the blockchain. Like for example, weather reports, something like that.
Yes. Yeah, exactly. So why do you think we need it in smart contracts? Bitcoin smart contract. Why not just the smart contract can read from, let's say, a weather station or something? Why do we need an oracle
For
for this?
example, to pull the rates of coin exchange, something like that.
Mm-hmm. So why do we need an oracle for this? That's I'm asking. Do you understand why?
Because if there will be like not exact value, it could be used for something like flash loan attacks or something else, where like a little difference can make a lot of money loss.
Mm-hmm. Yeah, that's one big reason. Okay, so for people who have not heard, yeah, that's very good. I think you know a lot about the oracles. So for people who have not heard about this term, so basically, for blockchains, right? They have usually they have a distributed environment where multiple nodes they have to reach a consensus. So usually they have to, if there's some information they need, if it's from on chain, because the chain is synced, so they can reach consensus, right? But if for any information that's outside of chain, the blockchain, for example, Vladimir just mentioned about pricing information or weather information. There's no, let's say, source of truth, single source of truth for this, right? For example, if every node is going to say, "Hey, what's the weather like in London today?" I think they may not always reach consensus. Or if there's some malicious nodes, right? They may say, "Oh, this is sunny," but actuality is raining, right? So the nodes can get out of sync. So that's why whenever that's the biggest difference. I think if we use a fancy term Web3 for smart contracts and blockchain, it doesn't have you know, it's like a black box, a sandbox. It doesn't know external data. So versus web two, right? You can usually hook up with some kind of like a RESTful API. You can fetch, you can query data from the database or some kind of web APIs, but it's not possible for smart contract directly. So that's why we have this kind of like a trusted third party in between smart contract and external world. So what this oracle means is, hey, I'm saying, okay, if you ask me what's the weather like today for London, you are trusting me. I have a final say on this and trustworthy. So if everybody trusts me, and I can have a final say on the weather, and any smart contract can use me because I'm the only guy who's here providing this information. So everybody is synced on what's the weather like in London today. Okay, so that's basically the functionality why we need oracles, because smart contracts does not know the outside world. So in order for smart contract to access outside information, you need some kind of like a trusted third party, which we call oracle here. Okay, so why do we even want to access outside data in the first place? It's because in a lot of contracts, if you want to deal with let's say real world events, right, or data. For example, you have a let's say you have a flight delay insurance contract. Then you have to know whether the flight is actually delayed and how many hours it was delayed, right? All this information is not on the blockchain itself, so you need to access that. Or if you want to, let's say you have some kind of a sports betting contract, and you want to know which team, you have two teams, let's say play soccer, and you want to know which one wins, right? So all this kind of information is not natively on chain. So you have to trust some kind of third party to tell you the truth, so-called, fact, right? So you have to import it into the blockchain. So that's where the oracles come into play. Okay. So how do we, then the next question would be, so if I have some arbitrary data, let's say weather or pricing information or, sports outcome, how do I know in a contract this does come from a certain oracle, right? You kind of have to authenticate somehow to validate this data is actually right. So this is usually done by so-called digital signatures, right? So for example, you use, the oracle's public key, and then in the contract, you got the data, whatever data it is, it can be arbitrary, but also in addition, you also get a signature from the oracle signing this data, saying, hey, this data does actually come from me and has been verified by me. So you can trust it. Okay. So in the smart contract, you can just verify the signature's value. So once the signature is validated, the data can be trusted. Okay. Any questions so far? Okay, that's good. So then the next, straightforward question would be, okay, they have many digital signatures out there. Which signature scheme do we choose? I think if you are coming from the Bitcoin or the blockchain world, so the number one thing you can probably think of is so-called ECDSA, right? Because that's a signature scheme that used when you send some Bitcoin to somebody's address, right? That's a signature scheme you used. Okay, it's very widely supported and everybody knows about it. Here's only one problem. Okay, anybody have a guess on what's the issue if you want to validate the signature for using ECDSA for oracles here? Anyone have a guess? Okay, so I'm going to spoil it. Okay, so basically for ECDSA, especially on Bitcoin, you cannot validate usually, right, when you validate a signature, you need three things, right? The signature itself, the public key, and also the message that's been signed, right? So by default, the Bitcoin ECDSA, the message cannot be arbitrary data. It can only be the transaction that is signing. The data cannot be arbitrary. It cannot be, let's say, weather, or price, or sports outcome. It can only be a transaction. So it's very limited. Okay. But of course, you can re-implement the ECDSA using Scrypt. You can pretty much, in that way, you can implement the verification, even you can generate the signature on chain using Scrypt. But here's a slight practical problem. The cost will be quite big, because the signature verification is kind of expensive computationally. So which means, Scrypt and also transaction size is going to be big. I think it's going to be like 100 kilobytes at least. So if we want to use oracles a lot, because it's going to be integrated with the smart contract a lot, so we want something much more efficient. Okay, so that gives us to this term, so-called Robin signatures. Okay, so anybody of you heard about this term before? Anyone? Okay, so it's not surprising, because I never heard about it before I come into Bitcoin smart contracts and oracles on Bitcoin. So let me just give a very quick introduction. Okay, of course, you heard about this is the guy who invented. Okay, no surprise. So basically, it's another digital signature. It's an alternative to the so-called ECDSA that's used in Bitcoin by default. Okay, so why do we want to use this type of new signature scheme? Okay, as a hint before, ECDSA signatures is quite expensive to verify on a blockchain versus the Robin signature is very simple to verify. Okay, so here, I mean, I'm not going to bother you with all the math here. You can read it. I will put it in the show notes. But the short story is the verification is only a hash and modulation and square root, and then compare whether it's equal. So it's very efficient. Just probably only a few bytes. Okay, you can do the verification. Okay, so it's very, very efficient. So that's number one reason we want to use this kind of digital signature scheme. Okay, to verify signed data from oracles. Okay, so let's coming back. So this is if you want to know more, you can read about the Robin signatures here, all the details. And the good thing is we have already implemented in our libraries, so you don't have to re-implement everything, and you can just re-import it from our libraries. Okay. So to just give an idea here, let's say, I talk about the betting smart contract. Okay. So let's just say, let me walk through this example contract. So what does this do? So basically, two people, let's say Alice and Bob, they want to bet on the price of, let's say, BSV, let's say 1 month from now. Okay. So Alice says, yeah, let's each put 1 Bitcoin into this contract. And if the price of BSV is $50, 1 month later, I win. I take all the Bitcoins. Otherwise, Bob wins. Okay. So it's very simple, right? And then the obvious issue arises here is how does the contract decide what's the price 1 month from now? It doesn't know, right? Natively, because the data is not on the native blockchain. So that's why we need the, so-called oracles coming in here. So any oracle that is trustworthy and can provide this pricing information. Okay, so here we use so-called a waitlist on chain oracle. So this is oracle specifically designed for Bitcoin, and it's used Robin signatures, and also it provides quite a few different varieties of information. For example, you can have, say, exchange rates, or you can even have blockchain information, and you also have time. Okay, so mostly we use the exchange rates API here, oracles here. So you give the different pairs, let's say BSV USD T, and let's all ETH USDC. Okay, so it has all this bunch of information here. So this is a simple example here. So you can see, you have the pair of coins here. You have the price. Oh, it's quite high. Okay, it was some old data 125, and has a timestamp. It also have the signature. Okay, this is the part we care about most. It has signatures. So as you can call, it's using Robin. It has public key and the actual signatures here. Okay, so we are going to take advantage of using this oracle for the exchange rate. Okay, so let's just walk through this the contract in details. So here, we have a bunch of properties which we want to initialize. Of course, we have the the price we're targeting, whether it's above or below this target. We also have symbols. So basically, the pair of coins we're concerned with. So here, let's use BSV USDC pair. Okay, and also we have the timestamp 1 month from now. It's a range because the time maybe we're not. If it's within some marginal error, we are fine. So we want to, instead of put a specific number, we put the range. Okay, so we also, of course, because we want to verify it does actually coming from the waitlist on chain. So we hard code Oracle's public key, which is waitlist on chain, the Oracle's Robin public key. Okay. Any questions so far? Oh, it's good. Yeah, feel free to interrupt if you have any questions. Okay. So once we have all this information, then it's very simple here. So let's say, you have you have a message, right? Message is almost similar to this kind here. All the information we can see here. This is the message format that's been signed. So it also coming with a signature. So the first thing we can have is we have we can verify this the signature. Okay. So as we said before, it's like any other digital signature scheme. We need three things: the message being signed, the signature, and the public key. So if this passes, we know for sure this message has been signed by Watson, by Witless on chain oracle. Okay, so then we can, this is you can think about this is this is the serialized data. So we need to deserialize or parse it and to get the internal information. Here, mostly we're aware about the exchange rate. Okay. So once we have the exchange rate and we can know all of these attributes, right? For example, the time, we say, oh, this is 1 month from now. Okay, so this makes sure that the date is actually correct. This also makes sure the symbol is correct. It is actually for BSV versus USDT. It's not for BTC versus, let's say, Ethereum, whatever. Okay, so you make sure the pair is correct, the time is correct, and then you can decide, right, based on the the bet we arranged between Alice and Bob. So if the price is over the target, so the Alice wins, otherwise Bob wins, right? So whoever wins, you got the public key, and then you can check the signature. That's whoever wins, they can take the money. Okay. I think this should be very straightforward. Any question regarding the contract here? Should be straightforward. Okay.
Yeah.
Okay. Sounds straightforward. That's good. Okay. So I think this is a more explanation. Basically, this is what I just walk it through. So basically, you can using this library function, which we already encoded in the existing standard libraries. So you can just import, and you can just call it. Okay. And this is some more utility function. Basically, once you have the string or the message with the raw bytes, and how do you, kind of deserialize it to get the exchange rate, to get the symbol, to get the timestamp. Okay, so this is like a utility function. I'm not going to bother with you. You can, if you want to know all the details, you can read this tutorial. Okay, so this is the end. I think the full code you can find in our boilerplate again, boilerplate repo, and it also comes with all kinds of tests, including unit tests and also the tests that you can run on testnet. Okay. All right. I think this is the example. I want to show you how to use oracles and how to use a specific, let's say exchange rate oracle from Watson chain to how do you integrate into your own contract. Okay. Any other thoughts here? Comments? Any questions?
No.
Okay. Yeah. Okay. That's good. That seems so it's pretty straightforward, right? So that's good. So what if you want to use some other information, right? Let's say, here we use this oracle. What if you want to find some, let's say weather? Of course, you can also, because oracle here is not so-called centralized, so we don't run it, and this actually runs by another third party. So if you can always spin up some oracles to provide whatever information you want. You can also leverage the code examples here, so you can always spin up your own oracles. But then here's the thing, you have to be, the more difficult part is for people to trust you. So you can, if you want to run a very legit oracles, you have to provide, very accurate information. So people more and more, once you build up your reputation, that's how you gain more and more trust and then become a, potentially profitable oracle providers. Okay, so I think that's the most of the things I want to cover today. But at the last, I want to just give you some sense of, what's outside of this oracles. Okay, so we're here. We talk about, Robin signatures, right? And you can actually use this to assign any arbitrary data. Okay, so this is one way to do it. Okay, but we have another way. So this diverges a little bit. So previously I covered how you run oracles and integrate oracles in your contract. And here, I want to spend a few more minutes to cover different alternatives of, how to verify oracles or import data from the blockchain. You can also have ECDSA based oracles too. So this is as I said earlier, this is a Robin signature. You can sign arbitrary data very efficient, verify it very efficiently. But there are some cases, ECDSA is preferred, right? Because, all the wallets, all the providers in the Bitcoin system already are familiar with this, and they may already have this built-in, so it's much easier. So what are some of the use cases that you may want to prefer to use the so-called ECDSA-based oracles? Okay, so as I said earlier, the one big drawback of ECDSA is if you want to validate any kind of signature against data that's not the transaction, it's going to be expensive. Okay, so but here we can have a very efficient algorithm too to implement it. So you can look at the details here is based on some kind of elliptical curve math. We do some kind of optimization, but the basic idea here is you can still use ECDSA very efficiently if every time you are broadcasting the smart contract transaction, the oracle has to be involved. So here, right? So in this, the oracle doesn't even have to know this smart contract, right? Because the oracle, let's say, every minute or every day, it just publish some public data and sign it. It doesn't have to know the existence of the smart contract, right? Let's say you have its own website or API. It just periodically publish, let's say, weather data or pricing information. The smart contract here, it doesn't know existence. The smart contract even exists because there's only maybe one of these use case. The data can be used by anybody, right? So in this case, the Robin signature is good scheme because otherwise the contract size will be huge. Okay, but what if some cases every time you send smart contract, the oracle has to know about it. Then in this case, for example, you construct the smart contract transaction, and then what's left is for the oracle to sign it. If this is the case, you have an interactive. Every transaction has to involve the oracle. Then this is the alternative you can use, and in this case, it's quite efficient, and that you have the added benefit of reusing the ECDSA signature scheme. So in this case, every transaction you must the oracle is almost like a co-signer. So in this use case, you can also use ECDSA based. Okay. And any question about this? Okay. So all right, that's good. I think that's what I want to cover today. I'm assuming the oracle will become very popular as smart contract use cases continue to rise. So I think this is almost like a very basic building block for all the future contract developers. So I strongly recommend you to go through this tutorial. And if you have any questions, just reach us on social media, or you can just comment in the video comments below. Okay. All right. Thanks for coming every day. And before I close it, any final remarks? Anybody? Okay. Yeah, sounds good. It seems you guys are all understanding. So very good. All right. And we'll continue next week. and thanks for coming.
Bye. Thanks.
Bye bye. Have a good one. Bye bye.
Bye. Thank you so much,
Bye.
Jen. Bye.
Okay, thank you.
So it's
Bye bye.
as well.